Hello and welcome to the third part of the liquid penetration testing. In the previous lecture, we'll discuss on the penetrant testing materials. And today, on this third part of the liquid penetrant testing class, we will discuss on this penetrant testing method. So, student, let's start it. Penetrant testing methods. The penetrant testing methods basically are three types. One is water washable methods. Two is most emulsifiable methods. And the third one is solvent removal methods. So students, let's start with this water washable methods. In this method, all of the material used are water soluble. Following the initial cleaning and drying process, the penetrant applied shall be water-based fluid. Dwell time for various penetrant inspection method. After the dwell time, the rinse or penetration removal step is different for various application methods. Use of large volume of water would require facilities for adequate draining and disposal of the rinsed water. Developer application follow the rinse step. When aqueous developer are used, there is no need for a drying step period to the application of the developer. Hence, however, the part must be dried after the application. If non-aqueous developer is used, the part is dry. The part is dry before the developer application. Development time begins immediately after the application of the dry development, and as soon as yet developer coating dries on the surface of the part. The development step is complete whenever the movement of penetrant coming out of the defect has ceased. The typical developments are given here. So first one is clean, then dry, then apply the penetrant, then drain and rinse. From rinse, there is a three way. One is the direct aqueous, apply the rinse, after apply the aqueous developer, then dry and then develop. Then other the rinse to dry and developer and then develop. And another way for the non-aqueous developer, rinse first go to dry, then non-aqueous developer and then develop. After that, develop good for the inspection. In inspection case, there is a two things. One is accept and another is reject. Two things is happen. One is accept, second is reject. If it is accept, then go for clean. If it is reject, then rework or scrap. So this is the water washable method. For dry case, for aqueous developer, clean, dry, penetrant, drain, rinse, aqueous developer, then dry, then develop, then inspect, then accept or reject. If in case of aqueous, non-aqueous developer, then clean, dry, penetrant, drain, rinse, dry, non-aqueous developer, then develop, inspect, the result comes out. So this is the way of the water washable methods, the penetration testing methods. After the water washable method, next is post emulsifiable method. This method is a combination of this method is a combination of solvent and water based inspection. Solvent and water based inspection. The difference in between the post emulsifiable penetrant process and the water solvent washable methods are the penetrant used and the need for the emulsifier. So these are the basic difference. The penetrant which is used, and number two is the needed of emulsifier. These are the two main difference from the post emulsifiable methods than the water washable method. If solvent based penetrant is used and followed by the emulsifier application, it allows the remainder of the process to follow the water washable path. Follow the water washable path or method. For both hydraulic and lipophilic emulsifier may be used in this method. The advantage of post-emulsifiable system is that solvent penetrants that may be required for some parts may be removed by the water. So if I see the method, then first is clean, then dry, then penetrant, then drain, then emulsify. After the emulsify, go for the rinse. From here it's divided into three parts similar to the water washable methods: aqueous developer, non-aqueous developer, and dry developer. For aqueous developer, then dry, then develop. For non-aqueous, rinse to dry, then non-aqueous develop, and then develop. For dry develop, rinse to dry developer, then develop. After the coming the develop, it go for the inspect. Then coming out the result, otherwise it is accepted or rejected. If it is accepted, then it is clean. So most of the things are same in case of post emulsifiable methods and water washable methods. There are the only two things which is different, that is penetrant is used penetrant and need for the emulsifier. These are the two main different of post emulsifiable method than the water washable methods. So after the post emulsifiable method, next solvent removal method. Basically this process is oil based inspection process. Penetrant removal must be accomplished. The penetrant removal must be accomplished by hand, wiping the part with rag dampened with solvent. Solvent technique is most often applied for the inspection of either a few small parts or for localized inspection, such as in situ inspection of pipe wells, and pressure vessel wells, pipe wells and pressure vessel wells, and is most amenable to portability. So in that case, solvent technique is the most often applied for the inspection in these techniques. Otherwise it's small parts, otherwise or the localized inspection. The methods are: first is clean. After cleaning, then go for the dry section. After the dry section, then apply the penetrant on the specimen. After apply the penetrant, then drain it. For the draining purpose, using the solvent wipe, then apply non-aqueous developer. After the non-aqueous, apply the non-aqueous developer developed. Wait a few minutes and then go for the inspection. If it is accepted, then go for the clean, and if it is rejected, then go for the scrap or rework. So students, these are the solvent removal method, which is basically used only for the oil based inspection methods. So these are the three methods. These are the three methods which are used for the penetrant testing methods: water washable methods, post-emulsifiable methods, and at last solvent removal methods. After the penetrant testing methods, the next is sensitivity. Since the introduction of penetrant examination, various experiments have been conducted and methods have thus been formulated to measure the sensitivity. Sensitivity can be defined as the ability of penetrant to reveal a particular type of discontinuity. In a material. So the sensitivity is defined as the ability of penetrant to reveal a particular type of discontinuity in a material. This is related to fine or wide discontinuities which are deep or shallow in nature. Factors affecting sensitivity are the ability of the penetrant to enter the discontinuity and removal of the penetrant from the surface of the component without its significant removal from the defect. In addition, the penetrant must have the ability to come out of the discontinuity with the aid of a developer and to form an indication which is readily visible and to form an indication which is readily visible with the good contrast with respect to the background. That means the penetrant must have the ability to come out of the discontinuity, from the discontinuity with the aid of developer, and to form an indication which is readily visible and with the good contrast with respect to the background. There following is a list of various types of penetrant in order of decreasing sensitivity and decreasing the cost. First one is post-emulsifiable fluorescent. Then solvent removal fluorescent. Third one is water washable fluorescent. Fourth one is post emulsifiable visible dye. Fifth, solvent removal visible dye. And the sixth one, water washable visible dye. So this is the sixth list. One is fluorescent and second one is visible dye. So this is the list of the various system of penetrant in order of decreasing the sensitivity and the decreasing the cost. So high sensitivity and high cost for is most emulsifiable fluorescent, and lower sensitivity and low cost compared to this is water washable visible dye. Well, visible dye. It is so from here it is found that visible dye penetrant can defect crack. Visible dye can defect crack having width of approx 5 micrometer, where fluorescent penetrant can defect crack having a width range of 1 to 2 micrometer. So for the visible dye can defect cracks having the width of approx 5 micrometer, and for the fluorescent 1 to 2 micrometer. Visible width is 5 micrometer, and for the fluorescent case it's 1 to 2 micrometer. Let's come to the next. This is application. After knowing all these things, where we apply this liquid penetration testing. It is applied in the aerospace to identify the different parts of the aerospace, identify to check the quality for in case of automobile, railway, tools and die, inspection on reactors and tank. So in most of the cases, liquid penetration testing has been used. So it is easy to apply on the metal body and non-metallic body. So now comes to the benefits of it. It is simple and inexpensive. It is versatile and is easily portable. The application to porous, non-porous, non-magnetic and complex shaped material which are non-porous and of any dimension. Find out defects, cracks, seams, lack of bonding, etc. So these are the benefits. And what are the limitations? The limitations in this method testing is defect, surface flaws, non-porous surface of material, surface cleaning before and after inspection, deformed surfaces and surface coating prevent detecting. So these are the limitations. So students, in their liquid penetration testing, we will learn about its definition, its working principle, its procedure. Then we will discuss the penetration testing material. Then we will discuss on penetrant testing methods, sensitivity, application and its advantages and disadvantages. So class, on the next lecture session, we will discuss on a new topic. Till then, stay safe and stay at home. Thank you so much.